Alright, so good morning everyone. Welcome to Valenzuela FB Live Science 8. So, for today's topic, under the module of force, motion, and energy, we'll be focusing about kinetic and potential energy. So for today's objectives, we need to identify and explain the factors that affects the potential and kinetic energy of an object. And also, we need to differentiate gravitational potential energy to kinetic energy. Now, yes, or last week, together with Sir Vallejo, you discussed the Newton's third law of motion, which is law of interactions. On the first week, we discussed inertia and acceleration. So, we do have these two things to remember each laws of motion. So, for the first law, the two things that we need to remember are object at rest and object in motion. To sum it up, an object at rest will remain at rest, while an object in motion will continue to move with a constant velocity, not unless there is an external unbalanced force acting on an object. While for the second law, the law of acceleration, it is directly proportional with the force and inversely proportional with the mass of an object. So it is represented by the formula, which is force is equal to mass over acceleration. Now, for the last law, or Newton's law of motion, which is the third one, the law of interaction. So, in law of interaction, we have also two things to remember, which are the action and reaction forces. Alright, so, for example, I have here a toy car. Now, how much force is needed, or what do you think would be the force needed for the balloon to go farther? Do you have any idea? Alright, so the higher the force, the farther the toy car gets. Now we have two toy cars. The next question will be, which toy car will reach a greater distance? The bigger one or the smaller one? If you will look onto the air inside of it. Alright, definitely the bigger one, the swan. Why? Because it has more air inside of it. Next. So for the last question, what do you think makes the car move? Alright, so these are the forces. The action and reaction forces. The action force here, or on this example, is the air going outside of the balloon that pushes this balloon forward, which is what we call the reaction forces. And for the last question, how come that these forces were able to move the car? Is it by means of forces only? Alright, that is because of its energy. Next. I have here a game. This game is entitled Sounds Like. So, what you will do is that you will guess the word produced based on what it sounds like. Alright? So, are you ready? Alright, so let's start with the first one. So, first word. 10 seconds. Alright, time's up. So, the correct answer is potential. So, P-O-T-N-C-O. It sounds like, very good, potential. Next. Timer starts now. Write your answers on our comment section below. Time's up. So the answer is ability to do work. Right? So ability and then to do and then war arc. Right. Next word. Six, 5, 4, 3, 2, and time's up. So the answer is kinetic energy. So we have ken, net, tik, and nerd, and then chi. So if you sum it up, it sounds like kinetic energy. For the next word, 10, 9, 8, 3, 2, and all right, time's up. So the answer is gravity. So gravity sounds like rub, it, and then T. So gravity. So the value of gravity here on Earth is 9.8 meter per second squared. That is the acceleration due to gravity. So always take note of that. Next. You'll have 3 seconds to answer. Alright, time's up. So, if you analyze it, you have W, and then or, and then K. Alright, the answer is work. W or K. Okay, for the next word. Timer starts now. 5 seconds. New tone and then me, there. So the answer would be Newton meter or Nm. The symbol is Nm. That is the unit for work and energy. Next. 7, 6, 2, and 1. So what do you think is the word? Alright, so the answer is joule. So when we say joule, this is the basic unit of work and energy. So it is also known as Newton meter, or represented by the symbol Nm. And by the way, joule is represented by symbol letter J. Right. And for the next one, and time's up. So the answer for this one is velocity. Below C and then T. So when we say velocity, it is a vector quantity wherein it is a speed plus a direction. Speed which is scalar plus a direction. Right. For the last one, would be harder. Alright, time's up. Or this is what we call the outer G. And then this one is what we call the inner G. So the answer is energy. So energy is the capacity to do work. So as we've done with that simple game, so we've summarized the different words that we've gathered or that we've answered. So we have potential, kinetic, Newton meter, joule, energy, work, velocity, and gravity. Now, since we will be focusing on the energy, what do you think is the meaning of energy? Alright, so we have here a definition of energy. So when we say energy, it is the capacity or the ability to do work. Without energy, you aren't able to do any work. And for speaking of work, it is an abstract idea related to energy. Why is it related to energy? When we say work, it is a method of transferring energy. It is the energy that it is being transferred, not the force. Take note of that. And also, we can summarize the work by means of its formula, which is work is equal to force times distance. So the force traveled over a distance, and that is the time that you can say that there is a work done. But it will not be done if there is no energy. So also, take note that they have the same unit. So for the unit of work and energy, we have 1 kilogram times meter per second squared times meter. So we have 1 kilogram times meter per second squared is equivalent to 1 Newton, which is the unit for force. And then the force multiplied by the distance, which is represented by the unit meter. So if you combine it, that is what we call the Newton meter. And also, it can be called, or it can also be called as joules, or J, or represented by the symbol letter J. This joule or joules is coined right after James Prescott, or James Prescott joule. Alright. Now, way back to our example a while ago. The question is, how will you describe the energy inside this balloon? The energy, is it moving or is it stagnant or not moving? Okay, the energy here could be, or since it is not moving, there is a energy, or still there's an energy in it. While if it moves, there will be another form of energy. And that energy is what we call kinetic and potential energy. Okay, so now, how do we differentiate kinetic to potential energy? So let us try to see their difference one by one. So the first is, kinetic comes from the Greek word kinetikos. It means to move or moving. While potential comes from the Greek word dinetikos. So dinetikos means power. There's something inside, but it's not moving, or it's not yet moving. Next, when we say kinetic energy, it is coined as, or it is a term for energy of motion, moving energy. While for potential, it is a stored energy, stored within a single object or an object. And also, kinetic energy can be transferred between objects. It could be by means of collision, like when you play billiard, or when you see a car hitting each other. So it can be transferred between objects. While potential energy, it cannot be, or it can't be transferred between objects. It is within them. It is stored within them. Also, when we say kinetic energy, it is measured from the place itself. While potential, it is measured from the bottom, because it's something to do with the gravity. Later on, I'll be discussing that. And lastly, it includes the mass and velocity for kinetic, while for potential energy, it includes mass, gravity, and then the position or the height of an object. Alright, so for you to easily understand the difference between kinetic and the gravitational potential energy. So there are so many kinds of potential energy, like the nuclear or chemical potential energy, the elastic potential energy, and the gravitational potential energy. But by this time, we'll be focusing on the potential energy. Now, I'll be giving an example. So first, the potential energy. So for potential energy, this one shows the elastic potential energy, and then the yo-yo, it also shows potential energy, the gravitational potential, and then the apple on the tree. Also, are you familiar with this? This photo is from Philippine Star. So are you familiar with where it is located? Good. That is what we call the Angat Dam. So, Angat Dam, when it doesn't release water yet, it possesses a lot of potential energy in it. Right? So, what if they release water on it? So later we will discuss that one. But for now, I have here a question based on our definition of potential energy, or examples of potential energy. Question is, which do you think has greater gravitational potential energy? Is it the apple A, the apple B, or the C? Take note that the height or the position of the apple is 5 meters from the ground. And also, take note that they have the same mass or masses for apple. So what do you think has the same, or has more or greater gravitational potential energy? All right, very good. So if your answer is apple A, then you are correct, because the greater the height, or the higher the height, is the greater the gravitation or the gravitational potential energy it will have. Alright, so next. Another example is a car or cars on a hill. So we have two cars, which is named A and car B. So for the first one, it is 60 meters from the ground. And then the second car, the car B, is 100 meters from the ground. So which do you think possesses a higher or greater gravitational potential energy? Okay, so if you answered letter B, so you are correct. Why? Because it has higher position. So the higher position, the higher its gravitational potential energy. On our third example, we have books on the table. So as you've seen, we have two sets of books on the table. The first set is consisting of around 4 books, while on this one, it is doubled. We have 8 books. So take note that they have the same height from the ground. And also, they have the same value of gravity, which is 9.8 meters per second squared, the acceleration due to gravity. Now, which one do you think has the greater gravitational potential energy? Okay, so if you answer this one, then you are correct. Why? Because since they have they differ on their masses, but we must include, or we must know that the greater the mass, also the greater its potential energy. Alright, so we will not only base it by height, but also by means of gravity, and also we have the mass of an object. So those are the different factors that includes in gravitational potential energy. So we have mass, the gravity, and the height. Next, let us now proceed to kinetic energy. Now, what are the objects that can be included on our example for kinetic energy? So we have the released bow and arrow, or the released arrow from the bow, and then the apple or apples which fell from the tree. Right, so since they are moving, we can refer to it as kinetic energy. Another example is the dam. A while ago, the dam doesn't release its water yet. So it stores a great amount of potential energy. While on this picture or GIF, so it already releases water. That's why it has a huge amount of kinetic energy by this time. Now, which one do you think has greater kinetic energy? Would it be the dam, which the water flows around 40 meters per second? Or is it the waterfalls, which is the water falls 80 meters per second? Which one do you think possesses greater amount of kinetic energy? Alright, so if you answer this one, so we have the 80 meters per second, that is correct. Because it has higher velocity. It possesses more kinetic energy. Another example. We have the rock on a cliff. If it's not moving, then it possesses potential energy. But if it will move, so imagine the splash that will be produced because of these rocks. So the question is, which rock can produce a great amount of splash? Or we can somewhat change the question into which has greater kinetic energy. But the answer would be the same. Very good. So if you answer this one, this rock possesses greater amount of kinetic energy, then you are correct. Why? That is because of its mass, which is 50 kilograms. So, for today's episode, we will focus on the combination of kinetic and potential energy of an object under the module of force, motion, and energy. So, for today's objectives, we are going to identify and explain the factors that affect potential and kinetic energy by means of computation. We know the different factors that affect potential and kinetic energy. So for potential energy, these are the factors which affects. We have the mass, the gravity, and the height. While for kinetic energy, we have the velocity and the mass. Also, we know that the unit for work and energy is the same, which is 1 kilogram times meter per second squared times meter, or also known as joule, which is coined right after James Preston Joule. And lastly, as a reminder, just obey units list of energy. So what does it mean? You just need to get the first letter of each word. So we have J, O, U, L, and P. And that will be as the unit for energy, which is joules. And remember that 1 joule is equivalent to 1 kilogram times meter squared per second squared. Let us now proceed to the computation of the gravitational potential energy. So, what do you think are the factors, or what factors do you think are involved in computation of gravitational potential energy? Alright, very good. So we have the mass, the gravity, and the height of, or the position of the object. So the gravity, or the value of gravity, is 9.8 meter per second squared. That's why we can use this equation or formula, which is gravitational potential energy is equal to mass times gravity times height. And for easier computation, we can also use the triangle formula. Okay, so for now, let us have a sample problem. So as you've seen, you have your sample problem in which there are two sets of hammers. So the first one, or the first question, is which nail would be the first one to be nailed, and why? What do you think is the answer? Is it letter A or letter B? Okay, so the answer is letter B. So why? We will find out the answer later. For the second question, what will be the gravitational potential energy of sample A and B? Okay, so let us now proceed to computation table and solve. So for us to be able to solve for the gravitational potential energy, we will use the Greta method to solve the problem systematically. Alright, so for the first problem, we have the given. So the given problem is we have the mass and we have the height of an object. So for the mass, for letter A, we have the mass which is equivalent to 5 kilograms. 5 kilograms. And the height is equivalent to 1 meter. And the value of gravity, which is constant, 9.8 meter per second squared. Now, GRESA stands for the given, required, equation, solution, and the answer. So next, we have the required. So for the required, we have the GPE, for the gravitational potential energy. For the next one, we have letter G, that is for the equation. For the equation, Cp, for the gravitational potential energy, is equivalent to mass times gravity times height. So let us now proceed to letter S and letter A for the solution and the answer. So for the solution, we just need to substitute the value into the formula. We have Gv, gravitational potential energy, is equal to the value of mass, 5 kilograms, the value of gravity, 9.3 meter per second squared, and the value of height is 1 meter. So let us calculate. 5 kilograms times 9.8 times 1, that would give us the answer 49 as achieved for the gravitational potential energy. Question is, what will be the unit? So we just need to copy the unit. We have kilogram. And then the unit for acceleration, we have x meter per second squared, then multiplied by meter. You get it? Also, it can be rearranged as this. The gravitational potential energy is equal 49. And this formula comes familiar with you. This formula is for, very good, for Newton. So we have Newton times meter. So we have 49 Newton meter, or it could be 49 joules. That is the value of our gravitational potential energy. Get it? Now, we are not yet done. We will compare 49 joules to the second given example. So let's try to solve the other one. Right, so for the second one, we have the same amount of mass, which is 5 kilograms. And then the height is 2 meters by this time. And the gravity is the same. It's the constant. We have the 9.8 meter per second squared. For the required, we are still looking for the gravitational potential energy. For the equation, gravitational potential energy is equal to the mass times gravity times the height. So let us now proceed to the solution. Substitution. So we have gravitational potential energy equal to 5 kilograms. 5 kilograms times the gravity, which is 9.8 meter per second squared, times its height, which is by this time is 2 meters. Same process. 5 times 9.8 times 2. That would give us the answer 98. For the unit, we have 98 kilograms times meter per second squared times meter. If you want to make it shorter, you can also make it this as 98 kilograms times, you will multiply the meter to another meter, it will give you meter squared per second squared, and automatically, this is the unit for joule, for Newton meter. So we have 98 joules as our final answer. You get it? Now, let us proceed to the third or last question. So for last question, which has the greater gravitational potential energy? And why do you think so? So this is our answer for the first one, for A. Then for letter B, we have 98 joules. So which of them would you think has the greater gravitational potential energy? Very good. It is the second one, which is the 98 joules, the letter B. Why? Very good. The greater the height, the greater its gravitational potential energy. So did you get it? Let us now proceed to the next one, which is the kinetic energy. So for kinetic energy, what do you think, or what are the factors which affects the kinetic energy of an object? Great. These are the mass and the velocity of an object. And this is represented by the formula, which is kinetic energy is equal to half of the mass and squared the velocity. Also, we can use the formula triangle to easily solve the problem. Let us now proceed to sample problem for kinetic energy. So, for sample problem, as you've seen, there are two cars or sports cars which has different mass, but they have the same velocity, which is 10 meters per second. So the first question, which car will be the first one to reach the finish line, and why? Is it the first car, which has a mass of 850 kilograms, or the second one, which has a mass of 750 kilograms? For the second question, what will be the kinetic energy of samples A and B? Okay, so let us try to solve the second question before we proceed to the last question. At this time, we'll be using kinetic energy. The same process. We will use the GRESA, given required, equation, solution, and answer, or the GRESA method to solve the problem schematically. So the question is, what will be the kinetic energy of sample A and B? So for the given, we have the mass of the first one, which is 850 kilograms. And then the velocity is equal to 10 meters per second. Now, for the required, what do we need to find? So we are asked to find what will be the kinetic energy. We are looking for the kinetic energy of an object. Then the next one, we have the equation. For the equation, kinetic energy is equal to half of the mass and squared the velocity. Let us now proceed to the solution. So for the solution, just take to substitute the value, the given, to our equation. So we have kinetic energy is equal to 1/2 of 850 grams per kilograms, then multiplied by the square of 10 meters per second. Okay, so we need to get the half of 150. 150 divided by 2, that would give us 425 kilograms. Then we need to square the value of the velocity, which is 10. So 10 multiplied by itself, which is 100. And then per square per second squared. Okay, so lastly, we need to multiply 425 multiplied by 100. So that would give us the answer of 42,500. And for the unit, we have kilograms times meter squared over second squared. As we all know, that this unit is equivalent to 1 joule. So for our final answer, 42,500 joules as our kinetic energy. Now let us write the answer here. So for the first car, we have 42,500 joules. Now let us try to solve for the second part. Let us now proceed to the second car, which is a mass of 750 kilograms. The same velocity as the first one, which is 10 meters per second. For the required, we are still looking for its kinetic energy. And the formula for kinetic energy, we all know that kinetic energy is equal to half the mass times square the velocity. Now, for the solution, just need to copy or substitute the value for the kinetic energy is equal to 1/2 of 750 kilograms times square the velocity 10 meters per second square. Next. So 750 divided by 2, or half of it, 375 kilograms. Multiplied by the square of 10 will be 100 meters squared per second squared. Next, we will multiply 375 kilograms multiplied by 100. That will give us an answer of 37,500 kilograms times meters squared over second squared. As we all know, that this unit is something to do or is same to the unit of joule. So for our final answer, kinetic energy of an object for the second part, 37,500 joules. So let us now compare our answer to the first one. So for the first car, we have 42,500 joules. While for the second car, we have 37,500 joules. So let us now proceed to the third question. Which has the greater kinetic energy? Which one do you think is the greater kinetic energy? Is it the first car or the second car? Very good. It will be the first car. So we have 42,500 joules for the first one.